Hello, everyone, and welcome to this month's Python Exchange. My name is Cameron Riddell, and I will serve as your host. This month, we are talking about a very special tool. And the reason that I say it's special is because I started using this tool a little over a year ago, and I have not looked back. The tool of today is Pixi, which is a cross-platform, cross-language package manager that's built on top of the Conda ecosystem and integrates well with PyPI. It provides a workflow similar to other modern package managers like UV, Yarn, Cargo, but for every language on every operating system. In order to help us discuss the topic for today, we are also joined by our usual crew and some additions of host panelists. So we'll go ahead and introduce our host panelists, then we'll introduce Ruben, our guest, and then we'll let Ruben take it away. Our first host panelist that we are joined by is James Powell. James, you've been here every single month, time and time again. I'm curious, for anyone who doesn't know you or hasn't heard from you, James, what is it that you consider yourself an expert in, and what are you excited to hear about today?
I am excited today to hear about why package management seems to be this unending story of difficulty after difficulty. This is one area where I do not have a lot of expertise. And I'm very interested to hear where, as just a regular human being, this kind of stuff might actually be very relevant to me and the work that I do.
Fantastic. Well, James, it's a pleasure to have you. We are next up joined by Tom Caswell. Tom, can you share with us what it is that you consider yourself an expert in, or at least really good at, and also what you're excited to hear from Ruben today?
I'm Tom Caswell. I'm the project lead for Matplotlib, and also core developer at HiFi. So in these roles, I'm very familiar with the building and packaging and distributing of libraries with C extensions. I'm a big fan of the Conda ecosystem for the way it gets that correct with the additional system dependencies. I guess I'm interested to hear the current state of Pixi.
Fantastic. Well, Tom, thanks so much for joining again. We're also joined by Juan. Juan, if you could also share with our audience what it is that you consider yourself to be quite good at, and also what you're excited to learn about Pixi today.
Hi everyone. Hi, Cameron. Uh, so me right now as part of the DSSI division at NSLS2 here at Brookhaven National Lab, I'm part of the data engineering team and also serve the role of team coordinator for the complex current program. But being as part of the data engineering team, I'm active contributor and developer for the tile, which is people who are familiar with this is access data access service. We use it for scientific data, and because of my work in this actually in this project, I also have been recently very active with Pixi. I mean, have been started to use it a lot, and I'm very curious about what Ruben has, to share with us today.
Fantastic. And Juan, thanks so much for joining. I know that you are always running around wearing many hats and making sure that nothing is going wrong, or at least fixing things when they do inevitably go wrong. So thanks for taking the time to join us today. Last but certainly not least, we are also joined on our host panelists by Rob Schaefer. Rob, could you share with us what it is that you find yourself to be quite good at and what you're excited to learn about Pixi for?
Hi. Yeah, I am another DSSI member in the Brookhaven National Lab. I also wear a bunch of hats. I'm a bit of a jack of all trades. What am I good at? Anything that requires good mathematical foundations, I would say. I'm a huge fan of Pixi on almost every front. I found it to be fantastic, really. And I'm very curious to hear. I've heard some rumors that you might be looking into the ROS ecosystem, and I'm very curious to hear what the Pixi development was looking like there, as well as just generally keeping up with things.
Awesome. Well, Rob, thanks so much for joining. Now, that is our team of host panelists who will help us answer some questions or even pose some questions and lead us in discussion after Ruben shares some prepared remarks. Speaking of Ruben, he is the guest of the hour today. And As you've likely noted, well, he does a little bit of robotics, previously a robotics engineer, whose work has increasingly centered on one thing that many of us developers care about, and that is making tools feel better to use. After beginning his career in robotics, Ruben shifted his focus toward the broader challenge of developer workflows, bringing that experience to Prefix, where he now helps shape the future of modern package management and reproducible environments through projects like Pixi. Alongside the technical work, Ruben spends much of his time building community connections with users and learning directly from developers about the problems that they face every day. That combination of engineering, outreach, and genuine curiosity about how people work has made Ruben a very important voice in the developer tooling space. So, Ruben, with that, I would love to turn things over to you. You can share your screen and lead us through the remarks that you have prepared for today.
Yes, thank you, Cameron. That was a great introduction, and I don't think I have to spend a lot of time on that type of slide this time. So, as the introduction already prepared, I will talk today about Pixi, and specifically Pixi for Python. That is the main topic of this presentation. And as some of you that might know it already, it is a little bit like what UV is providing to the Python ecosystem. It is what Cargo provides to the Rust ecosystem, and it might feel like what Yarn provides to the NPM ecosystem. And I'll take you through that on what that looks like and how you can use that yourself. So if my screen wants to continue, yeah. So again, I'm Ruben Arts, currently a developer at Prefix.dev. I used to build robots, both for study and for fun. A lot of Python was necessary for building these types of robots. This was my study robot that I built in the university. Then I joined Smart Robotics to actually do real robotics as a job. And that actually led me into joining Prefix, because while working on these robots, the biggest issue that we had was just making sure that the whole development team could quickly start with a new project, could quickly update when a new release was out of something. And the painfulness of just getting that set up was really, really dragging our team along, and we needed to solve that problem. So we went into the package management issues that were around, and we found a solution using Conda. And that is where my journey started, and I switched my job to Prefix.dev, where we focus on making a better package management experience using the Conda ecosystem, and more about that later. So, as Cameron said, I really like to share the things that we are doing, because I think it's important for everyone in the ecosystem to learn what we're building and why we're building it. So what is the specific problem? Everybody knows pip install. The problem with pip install is that if you don't do anything special, it happily breaks your system and it will not be reproducible afterwards. So if you're running on an Ubuntu system or some kind of Linux distro and you installed all your base dependencies with, for instance, apt, and then do a pip installation on top of that, that it works might just be by luck or some other things going right, but that you can make mistakes is something that everybody has felt in their workflow. Next to that, the installation of any other type of extension where there's no wheel for your system, so no binary precompiled setup, is going to be very tough, because then you need to understand how to install compilers, you need to understand how compilers work and how to call them. And even if the PyPI ecosystem help you with the build backends, you might still end up with strange errors that you've never seen before. And that is an issue that we don't want. And then going from your local dev machine to, for instance, CI/CD, or even to production, can be very hard. Docker is known as a band-aid, but in my opinion, it's not a fix. And I will also come back to that later. So the work on my machine is still not solved. We're still dealing with very complex setups that are hard to reproduce. And that is, especially where I'm coming from in robotics, still a problem that we need to work on. And that's why I'm working on it today. So what is Pixi? Pixi is currently an open source project. Feel free to go to this link and you can look at all the code that we're writing. It's a cross-platform, cross-language package management system and a build system. This is something a little bit more new. So if you're not familiar with that yet, I will definitely explain more about it. The experience that you will have is similar to UV, Cargo, and Yarn, as specified before, but it will work for every language on every OS. So it works well together with these systems, or it can extend them. Where it is getting its power from is the Conda ecosystem. So it's built on top of the Conda ecosystem, and it uses Conda Forge for its packages so that it can install any type of dependency. And then what is the first problem that everyone comes when they use Conda is that the PyPI ecosystem is too large to then install into the Conda environment. So we actually integrate UV, the Python package manager, into the Pixi binary, where we can solve these two problems at the same time and give you an experience where the environment that we'll create should actually work and should not have conflicting dependencies. Then when we talk about Pixi, you often talk about the ability to have a manifest and a log file, and these things are either the Pixi TOML or project.toml and a Pixi log file. This is similar to other ecosystems. We support binary and source dependencies, so you can either download direct precompiled binaries from the channels or the PyPI index, or you can actually locally build source dependencies. This is the cool feature that I will show you at the end of the presentation. And especially this is super interesting for setups where you need multiple languages. And this is something within this ecosystem that you are coming from, very important. So for instance, data science, AI, they often use not just Python, but also the need for like C, C++. These days, a lot of Rust, but especially in the old days, Fortran had a very, very big user base. And with all the NVIDIA stuff coming in, CUDA is one of the biggest topics these days that we're working on. And again, it works on Linux, Mac, and Windows. I will probably say that too often, but I really need you to understand that that works. So why should you care? Why is this very important to this ecosystem? Already SciPy, NumPy, and Pandas are switching over. They are using Pixi for their environment management. There's currently over 32,000 packages on Conda Forge, so it's not a small project anymore. There's a lot of packages that you can already get that are pre-compiled and are ready to use. And very important also with, for instance, CUDA drivers and everything related to that, which is always very hard to do. Then we're currently at 7K stars. Please give an extra star if you like the project or if you're using it. We're still growing. We're a very nice community around it. And yeah, we're always happy to help. And then research and universities is very much picking up our work, making it grow very naturally, where we have a lot of people that come from the scientific background and they just want to make their stuff work. So if you have used one of these package installers before, you might already know what Pixi will feel like. So you always have an initialization command. You always have a command to add a dependency. There's a command to run certain tasks. In Pixi, that is an actual command line task that you can run, similar to how Yarn would work, and not like UV or Cargo where you run only its language binary. You have an install task, which is just the task that does the basic execution of what the manager is taking care of. And there's always a log file added, which is similar to these other ecosystems. So it's a similar workflow. If you're experiencing one of these before, you will feel just right about home with Pixi. So to give you a little bit of a quick comparison, and obviously I made this so Pixi checks all the boxes, but Pixi can install Python itself, which is something that not every tool can do for you. Pixi always creates a cross-platform log file, so it can reproduce its own generated log file on the other systems that you want it to. It supports multiple languages. This is coming from Conda, and that's why Conda and Pixi ship this. The ability to use PyPI and Conda dependencies in one tool is only working with Pixi, and that's something we're pretty proud of. The ability to use Pixi as an installer for global CLI tools is something that's really powerful. So you're not limited to just your Python libraries or a C compiler. You can actually also install, for instance, the GitHub CLI or the AWS CLI and much more. And we have the ability to build packages from source, just like most of the Python package managers, but not just Python packages. And again, I will come back to that later. So what is the Conda ecosystem? For those who haven't heard of it, I heard a lot of people already knew it, but to give you a summary, it's a complete cross-platform, cross-language package ecosystem. And I want to emphasize ecosystem because the name Conda is used for both the whole of the Conda ecosystem, which includes a lot of tools, which includes an open source and shared maintainership. And then there's the package manager itself, which is also called Conda on the CLI, and that can install Conda packages from the Conda ecosystem. There's much more tools within this ecosystem, like Conda itself, Mamba, and Pixi, but also related to those installers, there's different types of tools that you can use. Then, why is this so powerful? It all started out when NumPy needed to ship with Fortran and C compiled code, and this is where Conda was built for. So the ability to ship a pre-compiled library for the Python ecosystem, which was at that time not possible with simply shipping wheels as it is today. And that made it perfect for also shipping those other languages, because if you want to ship the Python libraries written in C and C++, you also need to be able to do the installation of the compilers. And that just grew into an ecosystem that works well for a lot of different languages. Then packages live on channels, which is an index in the PyPI ecosystem, which is a registry in some other ecosystems. Everyone has a different name. Just know that if I'm talking about channels in this presentation, I'm meaning the bucket of binaries with some extra data that the installers need to properly get the right packages for your setup. Then there's always an environment that is isolated, similar to how the VNF isolation virtual environments work, where you need to activate that environment to use it. Then, it's again built by the NumPy and Numba creators, Anaconda, and we're working together with them a lot to improve all of these features these days. It builds using recipes, so where it's like similar to a project.toml that defines the dependencies, some metadata of the package, and for instance, the name and the version, and a build script similar to, for instance, CMake list, where you say, okay, I need these dependencies, this is the name of my package, this is the build script, and then if you then build that recipe, the resulting product is a Conda package. Then what is Conda Forge? Conda Forge is the community channel that completely powers the ecosystem from an open source side. There's currently 32,000 packages, which are all community maintained. There's over 7,000 community members that manage different packages. One recipe per feedstock, meaning that every package that is on there has its own repository on GitHub that is managed by one or more people, and then that contains that recipe that I just talked about. It is curated, so this makes it a little bit more trustworthy, where we can just make sure that before a package is pushed, it is reviewed, it is checked, and then people can maintain that recipe afterwards. And that also brings us to something that came up a lot these days, where people can just push binaries from their developer machines directly to, for instance, PyPI or Crates.io, where there's no view on what was actually pushed there. In the Conda Forge ecosystem, everything is run in these public CI systems, and we can always go back to see like what actually happened to create this package, which is a feature that is becoming more and more important. Then, why is Conda Forge so nice for Python? And what will you get from Pixi from day one, because it uses Conda Forge? So it ships Python itself, it ships most of the libraries that you're probably using these days, but it also ships CLI tools, so you can do much more than just the Python installations. It will ship all kinds of Go and Rust and other types of binaries that you might use on a daily basis. And with that, you can use Pixi to basically set up the grunt of your environment, not just the actual project environment that you're running. And it also ships something that's very important these days, the ARM builds for either Linux or OS X, which is a growing ecosystem that is very important. And if you're then still missing something, Pixi has the ability that you say, I want to add a package, but I want to get it from PyPI. And then if you're missing something, this will solve all of your problems. So Just to get into some basics of how you can use Pixi. First off, you will start with the init command as previously mentioned. Then you will get a workspace. This is what we have as a main entry for the Pixi toml. On the right, you see the Pixi toml. I forgot to add that to this image. Then you want to add some dependencies, for instance, Python, NumPy, and Pandas. Pixi will solve that environment and add the dependencies with a certain pin so that when you update afterwards, it doesn't completely break your current working environment. There's a lot of commands to deal with how you want these packages to be pinned, but this is the default workflow. And then you might want to add a package from PyPI. Obviously, Rich is also available on CondaForge and as a Conda package, but in this example, I'm pulling it from PyPI, and then UV will do the solve for us to get Rich installed. And after that, when my environment is installed, I can run tasks in these environments. So as previously mentioned, Pixi has an isolated environment, and then I need to activate that. To activate that, I can either run Pixi run or Pixi shell. And with Pixi run, I can directly give it a command that then will be executed in that environment. And for this example, I'm just running some Python code. So there's one manifest and it creates one log file with that. If you have dependencies, these are Conda dependencies, and if you have PyPI dependencies, we'll take them from PyPI. Then, when you want to not have a Pixi toml, but actually want to use the PyProject toml, you can actually just already add Pixi information to your PyProject toml. So if you do Pixi init on an existing project, it will add these required definitions that Pixi needs. And that's basically only the Pixi workspace. The project as it is can stay as it is because Pixi can also read this part. It uses the dependencies in this list as PyPI dependencies to give a similar experience to what you would get if you use UV. And it will allow you to extend any of the definitions that you do in a Pixi toml in your PyProject toml by adding this tool.pixi. The requires Python definition will be used instead of the Python dependency that you would normally get from the dependencies list. So this is a special case that the PyProject.toml has. And then this will create the same Pixi log file as the Pixi toml. So it doesn't really matter. It's just a matter of what you like more. Do you want to split the Pixi workflow out into a separate toml file, or do you want to keep it in your PyProject.toml? Then an often encountered example that most of you will probably see sometimes is the need for PyTorch either on GPU or CPU. To do that in Pixi, we will first add the system requirements. So we already defined a few platforms that we want to add to this workspace, and then we say, okay, also this this workspace needs CUDA. So you say system requirements CUDA 12.8, and then we can add PyTorch as a dependency. If you do this, if you add the star, it means I don't care about the version. I just want the latest what you can get from me. Then, because we defined the system requirements, Pixi will know, okay, I can take PyTorch, and if I can find a CUDA version of PyTorch, I will take on that one. That is great, but now you have a situation where your environment needs CUDA to run. So that's something you told Pixi, you have a system requirement on CUDA. But this is something you can split out. So Pixi has the ability to do multiple environments in the same workspace. And in this example, I'm showing you that the system requirements are part of the feature GPU. And then I can create another environment that is called GPU with the feature GPU. So these features are the building blocks of your environment. So if you want to have a lot of different environments, for instance, for different versions of Python, or for GPU versus CPU, or something we see more often is where you have, for instance, different simulators that you want different environments for, but the base application also works for both of them. Then you can write them up in separate features and combine them in these different environments. And in this case, that gives you the ability to spin up a separate environment, in this case, GPU, and then you will have the GPU enabled dependencies installed. Obviously, this is a special case for OS X because there's no CUDA on OS X these days. So in this case, that will just solve as normal. If this was incorrectly defined, you will receive an error. Then to give a little bit more information on the tasks that you can have, I already showed you can do Pixi run and then Python something, but you can also predefine these tasks in your Pixi TOML. In the basic form, it's just an alias. For instance, if you would Pixi run test, you could make that PyTest, lint, rough check, etc., etc. But this becomes more powerful when you do complete trees of different tasks. So for instance, if I always want to run a few set of tasks in my CI, I can make that one single task and I can run them all at the same time. So Pixi run test will run PyTest, Pixi run lint will run rough check, and Pixi run CI will run all of these in the order that you have defined them in. This is a pretty powerful tool to run any command on any system, which is also important because the definition that you do here is in a special built-in shell that is not needing you to understand PowerShell on Windows or CMDX and then ZSH on macOS and then Bash on Linux, for instance. This will just run in its own thing and will just work on any platform after you've defined it. But maybe you need a little bit more power than just the default environment experience where you install your dependencies. You can actually start building packages with Pixi. So I already told you that the compilers are all shipped on Conda Forge for C++, Rust, Fortran, etc. And Pixi can actually build that, use those compilers to build your current code into a package, which you can then ship, just like your normal Python packages, but with the ability to have all the build dependencies in one workflow. So just like the Python ecosystem, we've chosen for the build backends type of workflow, where we have multiple build backends for different types of languages. So we have a build backend for Python, for CMake. I actually have an image for this. So Python, CMake, Rust, and maybe even a very specialized recipe that you want to build. We have different backends for that. And for you, the most important is probably going to be the Pixi build Python backend, which understands PyProject.tomls and can actually already deal with things like Maturin or Hatchling, where for Maturin, it understands that you need the Rust compiler and stuff like that. So it makes it easier for you to go from I have this PyProject.toml into I need a Conda package as an output, which allows you to do source dependencies in your workspace. And that is what this will look like. So you will have one, if you set this up with Pixi, you will have one workspace with the main workspace defined in the top level Pixi TOML. And then you can have, for instance, a source folder with multiple different Python packages with all their own PyProject TOML. And then you can add the information you need there. So in this case, we have one with just Python, one with Rust, and for instance, some CMake stuff in there. You can do Pixi run, which will rebuild the whole setup when necessary. So if it finds that your Rust code has a new line in there, it will automatically recompile your setup and Pixi run will immediately have your environment up and running. All of this is then locked in your log file. So you'll always get the log file with that, where also the build dependencies and the host dependencies are locked down. So if you used CMake or a certain compiler when you were working on your own machine, if you then commit that log file to Git on your CI system or your colleague system, it will also use that version of the compiler, making sure that you don't have these weird build issues when the compilers don't connect. So what does this file look like? You currently do need to set the preview mode of Pixi build because this is currently in a preview state. But then you can define path dependencies for Pixi projects. Which looks like this. Then what does the PyProject.toml need to be able to be built with Pixi? You just need to add which package build backend you're going to add. So similar to the build system where you say, I want to use Hatchling, for Pixi, you need to provide that you're wanting to build this with Pixi build Python, which is also a backend that then understands the rest of this PyProject.toml. Not much more is needed if the rest of your PyProject.toml is set up correctly. To give you a little bit of a comparison, if you want to do this for another type of project, for instance, a Maturin project, you also still just have to add this Pixi build Python backend because it will take care of the rest of the dependencies and reading the PyProject.toml doesn't need much more. This is the power of these backends where it can understand the ecosystem that it's building for. Then as soon as you want to build these packages, In the example I just gave you, it will build them into your workspace and you don't really have to think about what is happening on the backend. But you might want to ship this to your colleagues as a binary, so you don't have to let them recompile everything that you're doing. So what you can do is you can set up your own channel and you can actually publish the code directly there. So if you're using our hosting provider, you can log in and then you simply run Pixi publish on the package package toml where you are, say which channel you have to post it to. It will build that package for you and it will ship that to your own channel. Then in a Pixi toml of someone else, you can just simply add the dependency with the version that you want it to be, and then Pixi will pick it up without having to recompile it from source. So where building from source is really powerful if you want to do something very specific or you want to develop on the code. Afterwards, we want to make it as easy as possible to not have to ever build that again and just ship that to people who want to use your code. And yeah, just as a little shout out, we have a free tier that you can get started with. So you have a lot of playground to ship some packages to your colleagues already. Then, if you want to ship anywhere, so you don't really want people that are installing your code to care about, oh, I need Pixi, I need to understand how to run a few Pixi commands, but you just want to grab all of your code and dump it somewhere else, there is a very cool tool called Pixi Pack, which is something that we've seen a lot of users use, where you can call Pixi Pack on your environment and, for instance, say that I want to build it for a certain Linux platform. It will create me a tar file and then I can just ship that full tar file to my other machine and then call Pixi unpack on there, and it will actually do all the installation, do all the extracting, and it will provide you with an activation script to activate that environment, and then you can directly run your, for instance, Python script without needing any extra information. This can actually be done by simply unpacking the tar file itself. You don't have to have Pixi unpack on that machine. And then it is like a fully self-contained shipment of your environment. Which is something very important for the robotics side, which I'm not going to talk too much about, but when you are air-gapped or when you are really struggling with internet connection, this is something really powerful because you can ship your environment with a USB stick. Then, if you want to use Pixi for more than just this workspace, where you have like a whole setup of your Python project, you can actually use Pixi Global to install any type of CLI environment. And what this looks like, it will install it into the bin folder of your .pixi folder, and there all the binaries are added to the path so that you can run them directly. Every one of these environments is then also isolated, just like you're used to with the workspaces. And this is a similar experience to pipx, if you know that already. And that allows you to install all of these dependencies without breaking any of the other dependencies when you install something new. And if you then want to share that with your colleagues or make sure you add it to your own dot files, there's one file that lists all of the dependencies that you have installed globally, so that if you will go to a new machine, you can just grab this one file and it will reset up all of your most loved CLI commands that you're using. So to give a quick conclusion, when do I use Pixi? I use Pixi when there's multiple languages involved. This is where it really shines. When there is a set of complex dependencies, so think big trees of C++ dependencies, or CUDA, for instance, is a very good example of when I want to use Pixi. When I want to do cross-platform projects, so I want to make sure that both Windows and macOS and Linux are supported. Pixi is a really good contender because it can pre-solve for all of these environments at the same time. Then it also helps when you want to avoid Docker for your dev experience. So what we see a lot of people do is, okay, apt and pip are working together. If I do it in this exact way, I write that down in a Docker file, and then I will just ship the Docker image so that I don't have to think about this whole setup anymore. But this creates a layer of complexity that everyone has to understand. It actually has some runtime downsides, and in my opinion, is just a level of complexity that you don't really need when you're developing your own project. And this also makes it easier to reuse that in CI, because in CI, spinning up these Docker images is also going to take a little bit more time than just downloading the exact packages that you need. Pixi is also great when you want to install a very single tool. So it is not just useful for Python packages, but also for much more than that, similar to what you would normally use apt for, or Brew on macOS, or Winget on Windows, all in one tool that you can have just one command for. And that is the introduction to Pixi. I hope you like it, and I hope there's a lot of questions that I can answer to help you out more. Thanks.
Thanks so much, Ruben. That was absolutely amazing because I learned some new features that I was not aware of previously.
Awesome.
However, to kick off our Q&A and our discussion, if you're in the audience, please go ahead, use that Q&A widget, and you can drop your question in there. And I'd love to invite our host panelists to kick off our discussion. So any questions or comments from our host panelists?
Sorry, I might have clicked the wrong button here.
So I have a question, maybe a technical question. That is there a way to get Pixi to use Conda to solve the dependencies from PyProject.toml as Conda packages instead of as PyPI packages?
Sorry, because I was stopping the screen sharing, I missed the full sentence. Could you repeat?
So you showed how if you put your Conda config in your PyProject.toml, the dependencies that you have listed there turn into PyPI dependencies instead of Conda dependencies. Is there a way to can ask Pixi to treat everything as coming from Conda and never PyPI, without having to duplicate your dependency list?
Yeah, so that's a big request, and we're still working on that. If you're using the Pixi build feature, you can actually say, okay, I depend on my own package, and then you can say everything should be a Conda package. This is, however, not implemented yet in Pixi itself, so you can't turn that on for a normal environment. This is definitely something that's on our list. We are now, because of the building system, moving more into what the mapping of these packages look like, because that's the most important part. NumPy to NumPy is pretty easy. OpenCV to Python OpenCV is pretty easy, but this becomes very complex very quickly. And this is the part that we need to solve before we can do that. We have a project set up that has been used for a few months now, but we need to integrate that the solver actually takes over there. But so the quick question is no, except if you're using the build feature where it can do that mapping for you.
Yep.
Building off that, Ruben, I was curious. I spoke with Daniel at PyCon just this past week, and he mentioned that I think Conda was also working on building out a full mapping of PyPI to Conda packages. Is this related or the same effort?
So you're actually how do you say that, on the bleeding edge of what's going on within the Conda ecosystem these days. Yes, we have worked on a lot of features to make sure that we can fully support the whole of the Python ecosystem, because a few very important parts of it are, for instance, the ability to do optional dependencies, the ability to do extras, the ability to define I only want this dependency when my Python interpreter is higher than this version, stuff like that. And since that is now out, we have been able to, or the Anaconda team has been able to convert the solver to actually solve the Python packages directly. So there is works where the Conda installer can now install direct wheels into a Conda environment. I am not super up to date today with what the status of that is, but I know it's an ongoing effort to make that a lot easier. Yes.
Fantastic. Thank you.
So, one quick question. So I was very surprised. Actually, I was not aware of that part that you could have, like Pixi TOML file managing, like, like a multiple language project, basically. Before I was just thinking, oh, and I need to just create this project for my Python code, and then if I want to, develop something in C++ that I will later use, in my Python code, probably with a wrapper or something, I might be thinking I might put this, in a separate project. Where having Pixi managing this, for example, if you have, if you're, developing these two parts of your project, if I know in one of my previous experience, when I add a new packages, I normally try to test my Pixi environment by just running Pixi update, right? Uh, does this still, I mean, is this still recommended if you have like these two, you know, mm, let's say two projects in different languages? Pixi will try to test your environment for both if you're, uh, I mean, probably understand what I try to say.
Uh, to try to explain what I understood,
Mhm.
what do you mean with testing an environment? Is
Yeah,
that
yeah, but basically, like if I add like a couple of libraries, one in C++, another one in my Pixi TOML, my second Pixi TOML that is handling the Python package. Like this structure that you showed, like that basically a tree structure, where at the top you have like the main Pixi TOML file
Mhm.
evaluating your project. Is this still like a recommended practice, or you still think that it's better to handle this separately?
So what that new setup allows you to do is let Pixie deal with a full workspace. So this
Hmm.
doesn't have to be a single root. It can be a single file. It can completely explode into multiple different projects. Pixie will require the package definition within that Pixie TOML or something specialized, like in the ROS workspaces, we allow you to use the package XML if you're familiar with that. And then Pixie will do the build of that package on the fly and then install it directly into your environment. So if you define a C++ package that just runs cmake build or install, and then uh, Pixie will create a conda file for that and then directly install that into your environment. You don't really have to know what's going on with that conda file there. It's basically just running the build script and then the installation for you.
Nice. Nice. Thank you.
Awesome. James, I see you have your hand up, but we have a couple of questions from the audience, so we'll tackle some of those first, and then James will come over to you. Ruben, our first audience question is asking specifically about, can you publish ROS1 or ROS2 packages with Pixi?
Ross, awesome questions. I wasn't aware there were people interested in robotics, but yes, you can. The thing is, with the ROS ecosystem, um, we don't have everything on CondaForge, but the ROS packages are on a separate channel, which is using the compilers and the Python interpreters from CondaForge, and then built on top of that, and that is called RoboStack. So every ROS distribution has RoboStack packages that you then need to use. So Pixie can use both of these distributions at the same time and then let you build ROS packages out of that, but you have to push it somewhere yourself. There is currently not a global bucket where you can just push and publish ROS packages or any type of package to that you built with Pixie. So yes, you can publish ROS packages, but it will not be on the main robotics distribution right now. We're actually in conversation a lot with the robotics ecosystem, open source robotics association to make Pixie a bigger part of their ecosystem as well. If you're asking questions about robotics, you might join ICRA, which is a big conference next week that I will also be joining. So please hit me up there if you are interested.
Fantastic. And I think a very good follow-up from that is another audience question asking about the current RoboStack coverage of full ROS2 Humble Jazzy apt package lists.
Awesome. I don't have the numbers, to be honest. I know that we have like a good basis. But the good thing about RoboStack is it's based on an automated script that translates the ROS index to the conda packages. And in most cases where you just need the Linux variant of that package, it will actually just need you to add the packages you need to a certain list, and it will grab that and it will auto rebuild everything that you need. And hopefully it's going to be not too hard, and hopefully most of it is already there, but I can't give you a number on how much it is. If you have issues, please contact us on Discord. We're very happy to help you with this, because robotics is where this project started and where I want this to move towards more. So please let us help and make sure that your workflow can work with Pixi.
Fantastic. Thank you so much for that. Now, another attendee question, moving a little bit away from Ross, but I suspect we'll have more, asks about Pixi using UV's implementation of a resolver, or does Pixi have its own resolver that it uses? And they're curious, is it PubGrub?
So this is actually a very interesting topic. We started out with the same solver as Mamba. For those who know Mamba, it's the package manager that has been built by Wolf, which is actually the CEO of Prefix right now. When it started out, we decided, okay, we need to rewrite everything in Rust. Initially, we rewrote everything in Rust except for the solver. That was still the same solver as in Mamba, but we quickly found out there were a few issues with that. So we actually experimented with, can we go to PubGrub? Can we go to other existing solvers, or do we need to do something else? And the problem with PubGrub is that you can solve ranges of dependencies. So you can say, I need this package between this and this range, and this and this range, and this and that range. But the Conda ecosystem has a very particular need within its dependencies. It's called a match pack. So you can say, I depend on version larger than this, smaller than that, but also for instance, a regex for the build string that you use. So for instance, if you want to say, oh, the CUDA build string, you can actually also say, I needed to have this license, or I need to have this file name. And it goes a lot further than what PubGrub could support when we wanted to try that out. So what we actually did was rewrite the same solver that was used in Mamba into Rust and then optimize the hell out of it. So it's currently similar to how the Mamba solver works, but just heavily optimized for the Conda ecosystem. And it's now actually usable for different ecosystems as well. So we have initially set up RIP, which was pip in Rust, which was a project that we started before the existence of UV. And there we actually rewrote that solver to also support PyPI packages. That worked, but because UV had already so much more on the side of like source building and all of the logic that was needed for the PyPI ecosystem, we decided to switch over to UV and let RIP rest in peace, and not having to deal with all the PyPI specialties that are needed to do the installation. So our solver could do the UV things, but UV didn't need everything that we needed, so they decided to use PubGrub instead of what we offered at that time. I think I answered most of the question with that. But cool question.
Oh, was there an official name for the optimized resolver that you had written?
Yes, it's called Resolvo. It's also on GitHub. It's also free to use. It's fully written in Rust. There's actually C bindings because Mamba wanted to use it. So yeah, there's a lot going on.
Perfect. Thanks so much. Now, a follow-up, slightly different topic realm though. You mentioned Pixi supporting or building with any language, and this individual is curious, what's it like extending Pixi to use a particular language?
Sorry, my headphones clipped when you...
Yes, they were commenting on how you mentioned Pixi with any language previously, and they were curious, what's it like extending Pixi to use or to build with a particular language?
So I hear two different questions that it could be. What you currently can do is extend Pixi with extensions. So if you have a binary that's called Pixi-something, Pixi will start up that package when you say Pixi space that package name. That might be something that you can write in any language, and then you can extend Pixi with that. But if you mean actually developing different languages within Pixi, that is where the basics of just installing the right dependencies comes in. So for the C++ ecosystem, we have the compilers, we have CMake, we have all the related tools for that available on CondaForge. And if you then want to do the actual building of these packages, there you depend on if there is a build backend available. These build backends are also, again, open source, so you could reuse the existing ones to rebuild for your own special ecosystem. So what we've seen already happen is that people build for Go or for R or for different types of ecosystems where we didn't start out initially, and we now also support that in a separate build backend. And this could be done for any ecosystem. The start is you need either the compiler or the interpreter of that language packaged on CondaForge, and from that point on, it can just grow. So we have NPM, we have all of these things are on there for people to play with.
Awesome. All right. And I believe the last audience question, so James, will get right to yours, that we have for now is taking us back into the ROS land. And they present a scenario. Let's say I have a proprietary sensor ROS2 package, and they might have some complex CMake options or some vendor-specific CMake flags that need to be used. Can Pixi ROS build or Pixi build handle that scenario?
So if you have proprietary software, the first thing I'm going to ask is it something that can be relocated, or is it like such a hard baked in package that like you need to drop in a certain location and only then it will work? This is where it can be pretty hard because we have these relocatable environments that you can install anywhere on your system. We kind of depend on the code or the package that you're installing to be able to make sure that it doesn't need this very specific installation on your machine. If that is the case, you can just repackage it and ship it, and it should be easy for the installation of that driver. Then, if that's not the case, you can still install it because Pixi is always installed on the host machine, or the environment is installed on the host machine, not like in a Docker. You can just access the binaries as is if it's on your path. So that will also just work. Then if you want to build those packages with Pixi build, you actually, like these backends are just a script that automates going from a certain type of ecosystem input file, for instance, the package XML or the cargo TOML or the PyProject TOML, name them, to a Conda package. So the default is prepared, but if that is not sufficient for your special use case, you can always either write one of these recipes that I pitched, where you just define exactly what you need yourself, or you can, with your company or together with us, build a separate backend for your special case if it would be required, which is something you would do if you have multiple types of packages that all have the same workflow. Building a backend is then probably the best way to go. And then if that is not necessary, you just need a few CMake flags. There's always the ability to add extra arguments to your build script through the configuration in your Pixi TOML.
Awesome. Thank you so much, Ruben. Now, James, I noticed that you had your hand up earlier. Was there a point of discussion or question that you had?
I think the discussion so far has been very interesting. I have a little bit broader of a question, which I'll phrase in two parts and direct to all of our fellow host panelists. The first part is, when we're talking about a package manager, we're fundamentally talking about a style of software development that we have enjoyed for many years, which is dependency. I'll just pip install or Pixi add or whatever the command is to add a new dependency. The first part of the question is, are we in a different era with thinking about dependencies, given the recent spate of vulnerabilities and the recent spate of zero-day attacks that we've seen? And the second part of the question I'll direct a little bit more closely to our colleague Thomas Caswell, who I think sits in two different worlds. One with the open source side, and then one with the closed source side, or at least the internal only side. For internal only facility-wide software, should a scientist in NSLS2 still be using a public Conda Forge channel, or should they only be able to use DOE managed, NSLS2 managed internal channels in order to be able to lock down or add in cooldown periods or implement some kind of policy so that they are not vulnerable to these kind of attacks? So again, the first question is, are we in a different era? And the second question is, should we make our scientists' lives even harder and make it so that they can't just install anything they want from anywhere?
So I think we are. I don't think we're a different era. I think there's been a wave of these things that have been very effective at extracting long-lived personal access tokens from GitHub Actions, and then using those to infect packages that then use to extract more and just like rolling through things. I think this is probably a local wave, and I expect this to die off in a few months as packages move away from long-lived persistent access tokens and secrets to something like PyPI Trusted Publisher, where you really need to get access to a maintainer's account and to push. Second, I think we do need to add. I think we've made releasing too easy on the project side. I think there needs to be a little bit more friction there, and like it needs to be a little bit more human intention. I'm not sure the right way to put that friction in, but I think just the releases need to be more perceptually expensive than they currently are. And I think a big advantage of Conda over going straight to PyPI or NPM is that there is at least a second step. And although you can set up the auto merge bot, a lot of the merges on Conda Forge still are someone going in and saying, "Oh, the auto tick bot rebuilt this. It's green. I the human am now going to push this button," and that delay adds in someone should be aware that happened and a little bit of time for someone to catch it. And in terms of locking things down, I think one cooldown period saying like nothing newer than 7 days could be a useful thing. But we also rely on we just did a hot fix. We got it through Conda Forge. We would like this on the floor now, please. We don't want to wait a week. So I think those have limited value. At this point, I think for a moderate security posture, still depending on public Conda Forge channels, which are traceable and built, are built on CI, is still a reasonable step. I think if you're in a very high security environment, that's where you might want to not trust that those things were built anyway, and you want to get in the business of rebuilding everything from scratch, or paying a company to rebuild that on their hardware in a more guaranteed way that you have contracts on. But I think for most moderate or low security applications, public Conda Forge is still okay. I mean, it's no more or less secure than Fedora or Ubuntu or any of these the Linux distributions. Sorry, that was a long answer to a somewhat straightforward question.
No, I think there's a lot of nuance in there, Tom, especially with the guidance of don't install anything newer, but also at the same time install as new as you can because there could be security fixes. We live in this rock and this hard place where no guidance is perfect.
I also want to hear what Ruben has to say, but I think I heard from Tom also, don't panic.
We'll get through this.
Yeah. No, yeah, thanks, Thomas. I think you gave a pretty good summary of also what I think about it. I actually, while we were talking, prepared a little bit on my second screen, so let me just quickly show you my browser again. Because like from a Pixi installation standpoint, currently we just can't just solve all of these issues at the same time. But as Thomas mentioned, there is ability to do an exclude newer in Pixi that can either be on the workspace level. This can be an exact date, or you can have like older than certain amount of days. If you then run Pixi update, it will check again and only take packages from that specific time that you defined it. And if you then have something very specific that you need from for instance, your PyTorch needs to be the absolute latest, you can say, okay, that one has 0-day time limit. And this works on both the PyPI parts and on the Conda parts. And next to that, what we're doing currently at Prefix is if you use our mirror of Conda Forge, so if you use https prefix.dev/Conda Forge instead of just Conda Forge on any of your Pixi tomls, what you'll get is a Conda Forge where quarantine has been executed on the packages. So as soon as we know something like the Mistral AI thing that happened a few weeks back, we can actually just click a button to remove a certain package from the CondaForge ecosystem before it even is done on a more top level index, so the Anaconda's Conda Forge. This is also, again, not a solution to never have issues, but it allows Prefix to have a little bit more control over what's going on. And currently this is done manual, but we're working hard on making this a lot more automated. And for that, we need to really understand well what package is linked to what source code or where these CVEs are found. So what we're working on is something of a preview right now, but what you can see here is where we are mapping certain packages to a package URL where we know exactly which package we're talking about in the Conda ecosystem. And because of that, we can link it to a CVE that is specified on those packages. And this is currently in development, but it will hopefully help us to make the channel a lot safer and yeah, something that we can monitor and proactively improve these issues on. This is all in big development. I think every ecosystem is currently doing something like this to make it a lot better. There's things that Thomas shared with just the slight extra friction that CondaForge creates is helping us these days, but it's not gonna solve the full problem. So right now we're either working on it or you can add these exclude newers to give you that little bit extra protection that you would like to avoid these 0-day attacks.
I didn't realize you had the package level overrides of the exclude newer. That's cool. I think Juan,
Yeah,
Juan and Robert, we may start doing that.
yeah, no, it's pretty helpful. There's actually one more that's not in this list, but you can also do it per channel. So if you have a custom channel that you use, you probably trust that. You could say 0-day on that channel and then 7 days on CondaForge if that's what you feel is necessary.
Awesome. And it's very cool seeing you all the track CVEs as well. I know I spoke with Zany at PyCon, and they're also doing something very similar at UV.
Yeah, it's like it's an unfortunate necessity these days. Maybe we're like I think everyone is actually late to this, and I feel there's no one that really solves the problem as a whole. But luckily, this ecosystem really is really open about it. So last what's it called? The open conference in Brussels. FOSDEM. There was a packaging room where we talked a lot to other ecosystems about the same problem, and it's a very open conversation, and everyone is doing their best to help solve this in a better way. Again, that will never solve 0 days completely, but at least the ability to take quick action is something that every ecosystem is working on, as are we.
Awesome. All right, we have time for one final question from our audience, and this is asking about mono repos with Pixi. In this scenario, they have 2 Python packages and a third Rust crate, and they're curious, can we do things like have integration tests in the root while applying everything? And they're thinking like this would be the equivalent for workspaces in Cargo, but of course for Pixi.
Yeah, so this is why this is currently on a preview. We are heavily debating on how to actually implement this because we have created a pretty big problem for ourselves where we want to do this for every possible ecosystem. This is something that's almost impossible to satisfy everyone. But what we're working on is the ability to run not just the build of a package, but also a separate task of a package. So for instance, the Rust packages can have cargo test and cargo format and cargo clippy predefined in the backend so that as soon as you use a Rust backend in Pixi, it will automatically also allow you to run tests on the full workspace. And then we can do the same thing for Python with PyTest and Rough, for instance, and have some of these nice defaults that will give a newcomer the ability to immediately start using stuff without having to first set up all of these things. But that will also allow you to do workspace level calls to a test, for instance, or to a format command that you don't have to always define yourself. This is currently under development. We're actually having a hackathon this sprint specifically for that problem. So again, very, very on the bleeding edge of what we can do. But yeah, this is something we're working on and hoping to get a nice solution for it.
Awesome. And would this also assist if I wasn't working across kind of like subtrees in these workspaces and just working within one, would this also improve the DX or the developer experience for that as well?
Yeah, hopefully. So if you have a single package and it is, for instance, a Python package, you depend on PyTest for your dev group, then I believe that Pixi should easily be able to pick that up and run the right test command for you in your setup.
Fantastic. Well, Ruben, thank you so much. This has been such a highly informative hour. I've learned so many new things about Pixi, and I'm very excited for the future as well, with a lot of new features coming out. So if we
Thank
get
you.
one final round of applause for Ruben, we'll go ahead and adjourn for now. That said, I do want all of our audience members to keep an eye on our website. That's meetup.doepy.org, because next month we're going to have Rich from Posit, who's going to tell us about documentation and share on a tool that he's been a part of, Great Docs. Thank you all for your time, and I hope to see you all again next month. Have a good one.
Thank you so much.